Hi there, Ms. Lams here. In this video, we would like to talk about independent variables. So just a very quick recap, what is meant by independent variables is what you change. So this will be plotted in the x-axis. There are two types of IV, continuous and discontinuous. The key idea is that if it's continuous, you will involve numerical values, such as how the concentration of glucose affect the number of bacterial colonies. And in the discontinuous one, usually you will express this in a bar chart, and this does not involve in numbers. And the fact that the conditions, experimental conditions, is in one condition but not the other, so it's exclusive. So usually students come to me and ask me which one is better, okay? So which type is better? Is it continuous or is it discontinuous? So actually, let's see what are the requirements for each of them. One is if you decide your IV to be continuous, what do you need? Generally speaking, you definitely, for all experiments, you need a negative control. In some experimental setup, you might need to have a positive control as well. And you need 5 increments so that you can establish a trend or correlations. And each increment should have about 5 repeats. So that makes up, including the negative control, that makes up 6 increments and 5 repeats, which makes about 30 trials. So some student will come and ask me, how am I going to do this in 30 trials, okay? And also you need to bear in mind the fact that this does not include your pilot studies. So my advice to you is definitely make sure you plan your time ahead. Do not procrastinate. While the other option is if you choose your independent variable to become discontinuous, what do you need? So the bare minimum is to include 2 increments. So for example, your negative control, such as distilled water, comparing with vitamin C. And each increment should have about 10 repeats. So that means if you're doing the bare minimum, then it will be 2 times 10, which is 20 trials. But do you think that you can get away with it? Now, usually, the answer of course is no. The reason is because in your background studies, you probably will have predicted the effect of vitamin C on the experiment result. So if you're just doing this one, and you are just confirming your theory, so that doesn't make a very interesting internal assessment IA. So what we usually recommend students to do is including another increments. So in this case, you're comparing 2 items plus a negative control. So such as the effect of vitamin B and vitamin C and against distilled water. So at least you can get an idea of, if you're comparing vitamin B and C, which one is better. So that makes about 30 trials, same as the continuous variables as well. So there's no which one is better or what. And plus, if you are doing this continuous variable, you need to do a 2-tail t-test. And in order to do a statistic test such as a 2-tail t-test, you need to have about 10 repeats per increment. IB suggests 10 to 15, so if you have time, of course 15 will be better. Yes, so that's the t-test. 2-tail t-test is actually quite complicated, so we're planning to cover that in another video. So until next time for the t-test. So what are the common distractor when it comes to the IVs? So sometimes when students were doing the experiment and somehow they got a bit lost and they thought that there are 2 IV. So for example, let's say they were measuring the plant's length on day 1, 2, 3, 4, 5, comparing with vitamin B and without vitamin B. Okay, and then they plot a graph something like this. And this is not correct, okay? So this is not the correct way of presenting, of answering the questions, the research question. Because in here, you want to see the effect of with vitamin B or without vitamin B. Okay, so whether with vitamin B will help the plant to grow better or not. Okay, but here, from this graph, what we can get is, okay, we notice that yes, vitamin B seems to grow higher than the still water, but you cannot explain it because what you're showing here is that the independent variable is the date. So my suggestion is stay focused. Ask yourself this question: what is your IV? Okay, your IV is with or without vitamin B. So you should expect yourself to have done a bar chart, okay, a bar chart like this. And you're probably wondering, oh, how am I going to do this bar chart to calculate the percentage change of plant's length, okay? Then that you need to set an end date, okay? So the end date may not be the last day of the experiment. The end date could be a few days before. So for example, let's say if you measure for 5 days and turns out day 3 is the best with the most differences, okay? Comparing with distilled water with filament B. Okay, so that reminds me of a movie, okay, of this movie saying that set the perfect timing, okay, to create a time loop, okay, so same idea. You'll find out a perfect timing to set your end date of your experiment. So like I said before, on day 3, you find that day 3 there's the most difference comparing to 2 sets of data, then you use day 3 as the endpoint. So therefore, if day 3 minus day 1 divided by day 1, okay, the length of plants times 100%, then you can calculate the percentage change for each repeat. Then afterwards, you will average it, and then you will calculate the FD. And then you will come up with a graph like this. So then student will come to me and say, oh, Miss Lam, I have done a lot of work. I want to present this of work, what I'm going to do with it. Actually, they have done a lot of work if you think about it. So there are 10 plants in distilled water, and there are 10 plants in filament B, and then they have been measuring this length of the plant for 5 days. They want to still keep it. So what can they do? I will suggest them to place it in the appendix and do not place it in the content. And the reason behind it is that you do not want to overload a lot of unnecessary data. For example, let's say if you are doing day 3, percentage change in day 3, then whatever happened in day 2 and whatever that happens in day 4 and 5 is irrelevant. So you will be penalized for presenting something that is not essential data, okay? And of course, you will be penalized for too many graphs and too many tables. And as usual, for the IA, there are a 12-page limits, and you do not want to exceed those 12-page limits. So that's about it for the IV. Okay, I hope that helps you to plan your IA. So, at all, keep up with the good work. Good luck, and bye-bye.